Hi, all. Welcome to the second session of the fourth series of free training. Agenda for today's session is to understand the application performance with APDEX code, monitor the code flow across applications via distributed tracing, pinpoint to the problematic elements in your application code, and visualize the dependencies in your application architecture with automated service map. Are some of the recent facts that we have gathered by trusted sources like International Data Corporation and Forrester. According to the International Data Corporation, 90% of the respondents are currently using the observability. This makes the management to have a deeper insight and to drill down the information of their application. And the Forrester's research report states that 87% of engineers said that using a cloud native architecture has increased the complexity of discovering and troubleshooting the incidents. Before discussing the topics in the agenda, let us start off with why an application performance monitoring is needed. Imagine an user who is accessing an e-commerce website and is trying to purchase from the online store. Completion of the selection of items, they are trying to attempt to place the order. And at the time of placing the order in the payment portal page, they encounter issues like the portal taking a long time to load or getting redirected to a different page or showing some error codes, etc. This could lead to losing of potential customers from accessing the application and leading to a loss of business. And for the developers who are working in this web application will be unsure of the root cause. So in this scenario, the demand for using an application has increased, which has also led to the complexity in its development. Hence, it is necessary for the developers who are working in the application to make sure that the website is bug-free and handle the load in the application's database to ensure providing a better service to their users. Here are some of the contemporary trends in the application monitoring. Let us see one by one. The first one is cloud native applications. Recently, large enterprises have adapted to move many of their applications to the cloud. The cloud native applications are scalable, flexible, and also efficient software that uses small independent building blocks like microservices, containerization, commonly Docker, and Kubernetes. Developers and the operation team work closely together using the DevOps practices for faster and more reliable software delivery, such that the monitoring these applications is essential, which helps in analyzing how each part of the application is working and try to fix any issues for handling a lot of users. Second one is artificial intelligence for IT operations. In the context of application performance monitoring, the artificial intelligence and machine learning in the recent times are used to enhance and automate the IT operations through anomaly detection for identifying the unusual deviations, automate the IT task, and predictive analysis for potential future using the historical data and optimize the resource allocation for scaling based on the real-time performance data. The third one is user-centric monitoring. User-centric monitoring shifts the focus from system-centric metric to the actual end user's experience when interacting with an application. Users' experience is gauged by examining their journey from the moment they access the application to the completion of their task and identifying user-centric metrics such as page load times, the response time, and the overall responsiveness of the application by helping the developer to prioritize improvements that enhances the user satisfaction. The fourth one is application observability. Application observability, including application performance monitoring, will help in gaining insights into the performance, behavior, and also the health of an application, which is achieved through monitoring applications transaction trace logs, execution time, and identifying the bottlenecks, errors, and inefficiencies in the code. The last is full stack performance monitoring. The goal of a full stack performance monitoring is to identify and address the performance issues across the entire application stack, from the front end user interface to the backend server infrastructure, by monitoring the various layers of the stack, including the application code, server response times, and the database queries. This is achieved by collecting the real time data on various performance metrics like the response time and the error rates. So, by adopting to these latest trends, which we have discussed, organizations can gain more insight into the performance of their application in the real time by enabling them to proactively identify and also resolve any potential issues before they are being impacted to the end users. So this will ensure that for maintaining reliability, availability, and responsiveness of modern applications. Let's explore some of the benefits of modern versus traditional approaches in building an application. In the traditional approach, the applications were hosted on an on-premise or a single data center servers, experiencing high downtime and limited availability, leading to the potential performance issues during their traffic periods. However, with leveraging the cloud computing and containerization for better availability and utilizing features like load balancing, redundancy, automatic failure, and global distribution has minimized the downtime, enabling continuous deployment without affecting the user experience. Earlier, the scaling traditional application involved purchasing additional hardware and substantial investment in the infrastructure. High maintenance costs due to the need for physical hardware updates and repairs. So, with the cloud based solution, reducing the upfront cost, allowing efficient resource utilization, horizontal scaling of resources based on the demand, automation, and containerization contributed to operational cost savings. The third one is global content delivery. Content delivery may be constrained to a specific location or a data center where the users in the different regions might experience latency and slower performance. Using the content delivery networks and edge computing will ensure a faster and a more reliable delivery globally. Cloud services offer the distributed content across multiple servers globally, reducing the latency for users worldwide. This improves the user experience and ensures consistent performance worldwide. The last is operational efficiency. Managing and maintaining the traditional applications will involve manual process for deployment, scaling, and maintenance with limited flexibility and agility in responding to the changing business requirements. Through the DevOps practices such as infrastructure as code, continuous integration and continuous deployment pipelines, and container orchestration, tools will automate the process, enhancing operational efficiency. The microservices architecture enhances agility and scalability for evolving applications. Updates can be rolled out seamlessly without any downtime, and resources can be managed programmatically. So in summary, adopting to a modern approach to building application will offer advantages such as improved availability, cost reduction, global content delivery, and operational efficiency when compared to the traditional methods. The cloud computing, automation, and modern architectural principles are key factors which will contribute to these benefits. So, enabling businesses to stay competitive and responsive to the changing demands. The modern approach will offer benefits such as improved scalability, reliability, global content delivery, which will contribute to a higher availability when compared to the traditional approaches. So far we have discussed why an application performance monitoring is necessary. In the Applications Manager, the performance monitoring tool is called APM Insight. APM Insight will give you an understanding the way your application is behaving for the end users who are accessing it. By a complete end-to-end transaction monitoring across your entire web application will help you to avoid any performance issues. Also, you can analyze the root cause of the problems much faster by performing the first level troubleshooting. The supported technologies in APM Insight are Java, Node.js, .NET Core, Microsoft .NET, PHP, Ruby Rails, and Python. These are some of the factors which will play a crucial role in determining the performance of an application. Let's see each one. The first is response time. When a transaction is made by an user in the web application, the request is sent from the application layer, which will travel through the transaction and the network layers and hits the application server. And this request is served back to the end user. The response time is taken for a transaction to be processed, which includes the time taken from initiating a request to receiving the final response. The query response time is taken by the database query to retrieve and return the data or the speed at which the database queries are executed. Slow queries can significantly impact the overall application performance. The application performance response time is the time taken by the application to respond to the user inputs or the request, which will include the processing time, the network latency, and any other delays. The application code. We know that bugs in the application code can lead to unexpected behavior, crashes, or performance degradation. Inefficient or excessive exception handling can impact the overall performance, and the frequent exceptions might indicate issues that need some attention. When an error occurs, a stack trace provides the information about the sequence of the function calls leading up to the errors. So, analyzing these stack traces will help in identifying the source of performance issues. The third one is memory. Monitoring the application's memory consumption is crucial. High memory usage can lead to performance issues and even crashes. If the application exhausts its allocated memory, it might crash to or become unresponsive. This occurs when the program doesn't release memory properly, leading to a gradual increase in memory usage over the time. The last one is database. Database queries that will take a long time to get executed can impact the entire application responsiveness. Optimizing these queries is very essential, and the number of calls made to the database can impact the performance. So, reducing any unnecessary or redundant database call can improve the overall speed of the application. Hence, monitoring and optimizing these factors are essential for maintaining a good application performance. Various monitoring solutions can help you to identify and also address performance issues in each of these areas. Also, regular performance testing and tuning are very essential for ensuring the application to run smoothly. The Application Performance Monitoring Insight is a tool that uses agents for monitoring the application. Initial step will involve in deploying the agent onto the servers where the applications are running. These agents are responsible for gathering the performance data and transmitting it to the applications manager for analysis. The agent within the application server utilizes a method called bytecode instrumentation to track the individual user transactions as they navigate through the application stack. It then will send this transaction data to the applications manager at a fixed time interval. The approach will enable a detailed monitoring of the transaction performance, facilitating identifying of the bottlenecks or any performance issues. The tool will offer code level visibility, allowing monitoring of slow database queries and their performance by capturing the real-time user interaction with the application. So users can configure any alerts and notification based on the predefined threshold for the metrics that impact their application performance. When the application performance breaches these thresholds, the tool will send alert to the IT team. So this alert system will help the developers and the IT team in pinpointing the areas that require improvement in the performance, such as application code, database related issues, and page load times. So this will proactive the approach helps address the issues promptly and to minimize the downtime. Exporting and elevating the performance using APM Insight Data Exporter. The data exporter, it is a standalone component or a module within the applications manager for collecting, processing, and sending application metrics and traces for communication with the applications manager server. Its purpose is to export the data related to the application performance monitoring insight. Data exporter operates as a separate, independent process, which means it will run automatically from other components or services within the applications manager. Primary function of the data exporter is to handle and transmit the information related to application metrics and the traces to the application manager. The metrics will include various performance indicators such as the response time, the error rate, or the resource usage, and the traces, typically which will refer to the detailed records of the execution flow of a transaction or the request within the application. A single instance of the applications manager data exporter is capable of managing data processing for multiple applications. This implies that the exporter is designed to handle the data export requirements for various applications simultaneously. The exported data is then sent to the applications manager server. The server will analyze this data and provide insights into the performance and the behavior of the monitored application. This is an overview of the data flow through the data exporter. The data exporter supports agents written in Python and PHP. These agents are responsible for monitoring the applications to capture their metrics and the traces. Developers or the IT team integrate the supported agents into their Python or the PHP application. These agents will collect the performance metric, the traces, and the other relevant data from the application. A single data exporter instance is set up, which will handle data processing for multiple applications. It acts as an intermediary layer between the application and the Applications Manager server. Application will continuously generate the data related to its performance like traces and the other metrics. This data is collected by the respective agents, that is Python and the PHP, which are running within these applications. Data exporter will process the collected data to aggregate, filter, and will format it appropriately for transmission. So this step will involve organizing the data in a way that is compatible with the Applications Manager server's requirement. So once the data is processed, the data exporter will establish communication with the Applications Manager server. It will then send the aggregated and formatted data to the server for further analysis and storage. Applications Manager server will receive the transmitted data from the data exporter, stores the data in a centralized repository, and will provide the user interface for monitoring and analyzing the application performance, traces, and metrics. So the system administrators or the developers or the IT team can make use of this data to monitor the health, performance, and the traces of the application, which will aid in identifying the bottleneck or the performance issues and optimize the application behavior. Folding the advantages of a data exporter. First one is APDEX score will be more helpful in improving the customer satisfaction. Second and the third one is using the enterprise tool, you can pre-analyze the data and enhance the security to reduce the network load from the application. You can alert your development team in prior and make your decision wisely before the application goes down, which can improve your application in efficiently communicating and provide the customized data transmission. These are some of the key performance indicators in the APM Insight. The first one is APDEX score. APDEX is a numerical measure of user satisfaction with the performance of the application's response time. The second one is response time. It measures the average time it takes for the application to respond to a user's request for the transaction across the application. So lower the response time are generally more desirable. The third one is request. The total number of requests made to the application within a specific time frame and helps to decide the overall workload and the usage of the application. The fourth one is data throughput. It indicates the amount of data in bytes transferred or processed in and out in the network request by the application during the monitoring period. This will help in understanding the application's data handling capability. The fifth is exception. It will track the number of exception errors or the failures that occur during the cycle of transactions in a chosen duration processing of the request. So these exceptions could be various types like the errors such as server errors, timeouts, or other issues that affect the application's normal operation. Let us understand the application performance with APDEX scores. The APDEX score is categorized based on the application responsiveness. The first one is satisfaction. So this category represents the highest level of user experience where the application's response time is between the satisfied threshold and the excellent threshold. So users in this category are generally satisfied with the application's performance. The second one is tolerance. The tolerance category indicates that the application's response time is between the tolerating threshold and the satisfied threshold. So users in this category might tolerate the performance, but may not be entirely satisfied as under the satisfied category. The last is frustration. So this category represents the lowest level of user experience where the application's response time is below the tolerating threshold. Users in this category are more likely to be frustrated with the application's performance as it does not meet their expectations. Tracking the application performance with the APDEX score. So this application performance index or the APDEX score, it is a standardized metric which is used to measure the user satisfaction and the application response time. The APDEX scale ranges from 0 to 1, where 1 being the best score and representing excellent user satisfaction. So based on the total samples that are collected, the APDEX score is calculated as sum of the satisfied plus half of the tolerating count over the total samples that are collected during the transaction. What are some of the advantages of monitoring the application performance with the APDEX score? Let us see one by one. The first one is user-centric performance measurement to understand the application behavior, which will help you to understand how each application performance directly impacts the user experience and enables you to prioritize the improvement. The second is easy interpretation of complex performance data with a common performance metric will simplify the complexity of the data into a single and easily understandable metric by providing a clear and standardized way to assess the application performance. The third is you can benchmark and compare the performance level of different applications, allowing you to identify the high performance application, leading to consistent improvement across your IT environment. The fourth is proactive issue identification and prioritization of code optimization. So when the performance falls below the acceptable level, the AppTech score will help you to identify the critical transactions with low scores, highlight the areas for code optimization. Alerts are triggered by enabling quick issue identification and improving the key transaction that impact the user satisfaction. The last is the historical AppDex trend data will allow you to analyze the performance pattern over the time, helping in understanding the performance trends and identifying improvements for ensuring a consistent positive user experience. And now you would be more interested on configuring the key business transaction to monitor the entire performance of the application effectively. In this slide, we shall see on configuring the key transactions of your business operation. Could be a high volume of activities made in the application. All the transactions would be captured, among which you can select the key transaction that you want to monitor in it and try to set a threshold based on the response time of the transaction. Moving on to monitor the code flows across application via distributed tracing. Microservice architecture, it is necessary to monitor the transactions made between two or more applications or the services. The distributed tracing feature, you can track the transactions made between two or more applications. Let's understand how the tracking is done in the distributed tracing. An API request is made by an application to another application. The APM Insight will add an HTTP header containing the metadata that is required to track the request. If the APM Insight is enabled in the other application, it will process the HTTP header and return the tracking information to its caller via response headers. If the other application in turn calls another service, the header propagation will continue and trace all the paths that are taken by the original application across the distributed system. So using this data, We can monitor the start time, that is when the transaction was initiated, the response time taken for the transaction to respond within the application, and the name of the transaction and the application. By clicking on the expand tree view, as seen in the screenshot of the application name, you can view the method calls and the code blocks that has taken a significant amount of time to complete the request, and this will enable you to monitor the calls made between two applications and narrow down the problem. Auto scaling in APM Insight. The auto scaling is an automated way of managing the resources of your application. Imagine you have a website or an application running on the cloud environment. Whenever the application automatically scales up due to the high user interaction in the site, and to handle this extra traffic, a new instance will get added. However, when these applications are scaled down due to lesser user transactions, or interactions, these newly added instances will become unused and are still retained. So this will lead to the license being consumed by the unused instances, resulting to the new instance not being added for monitoring. Hence, with the help of auto scale mode in the APM Insight, you can overcome this scenario by automatically unmanaging or deleting the unused instances in the cloud environment. Pinpoint to the problematic elements in your application code. Let us see the need for eliminating the issues in problematic code. As you are aware, stack trace represents the movement of an application during execution of a program. When the Java application throws an exception, the stack trace gets logged within it. By enabling the stack trace provided by the APM Insight, the developers can pinpoint to the exact line of the code and the sequence of the function calls leading to the issue. So this information will help them understand the root cause of the problem and can make the code optimization or bug fixes to eliminate the issue and improve the application performance. With the stack trace, the developers can efficiently troubleshoot and also resolve problems within the application's code, ensuring a smoother and a more reliable user experience. Gaining deeper visibility into Java-based application performance using context-based monitoring. You can enable the context-based monitoring for your Java application. This will allow the tool to track and trace individual user transactions, capturing data on how each registration transaction flows through your application server. Let us say your application server has 3 Java applications running on it. By default, transactions of all the application coming from the same application server are shown collectively under the Web Transaction tab in the APM Insight. In the image, as you can see, the Tomcat application is the application monitor name, and the JPEG store sample and sample web page are 3 contexts running on the same application server. The transaction of these 3 Java apps are listed out in the Web Transaction tab. Now, with the context-based monitoring, you can monitor the performance of all the individual applications running in the same application server separately, which will help you to analyze your application performance. This means that by enabling the context-based monitoring, the transactions of the JPEG store, the sample web page, and sample can be viewed separately as well. Going on to the last slide, visualize the dependencies in your application architecture with automated service map. So what is a service map? It will provide you a complete overview of the application infrastructure along with the connection to the other dependent resources. So the main purpose of a service map is to identify the status of the application and its related instances, monitor the key metrics like the response time, throughput, and the status of the connection, detect and troubleshoot any application problems before the customers are getting impacted, and also to identify the number of failed request count. There are three types of service map. One is map view, the other one is table view, and the graph view. Here in the map view, it will provide the way of analyzing the topological view of the application, and along with its instances are represented in the central node. Now let us look at how all these can be achieved in the APM Insight Monitor and discuss on generating the reports and configuring the alarms for the performance metrics. This is the Applications Manager, that is APM Insight Monitor. So here under the Overview tab, will provide you a summary of the overall application performance that are collected during the last 7 days, that is between 15th of October to the 22nd of October. So here, as you can see, it will provide you the APDEX score, the response time, the request, the data throughput, and the exceptions, which are the key performance indicators of the application. So if you want to monitor the individual transactions that are captured in the application, you can move on to the transaction tab. Here in the transaction tab, it will provide the details that are pertaining, which will help you to identify the transaction which has consumed a longer time, the frequently accessed transaction, a tier-wise breakdown of the transaction can be captured. So this is available in two views. One is the table view and the other one is the graph view. So we know that an individual transaction could have taken a longer time to get executed. So based on the average response time, these are the number of transactions that are listed. So when I click on any one of the transaction, it will show me the other details or the other performance indicators of the transaction. So here I can view the recent 5 traces that are related to the transaction or the most slowest traces that are related to the transaction. I will be able to monitor also the response time broken by the components like the application code, the database query, MS SQL, overall response time. So by clicking on the individual trace, it will provide me the method calls, the SQL calls involved in this particular transaction, the response code of it, and the method used for the transaction. Also, it will help me to understand the uh, response time or the CPU time, the memory used by this individual transaction. So as we had discussed earlier, these are some of the method calls and the SQL statements that are involved in this particular transaction that we are viewing. In the SQL statement, it will show the start time when that particular transaction was stated, the query that was involved in that particular transaction. Moving on to the database tab. So the database tab will provide you the detailed performance metric, that is to identify the slow database calls or the database usage and the overall performance of the database with a detailed graphical and tabular representation. So by clicking on to the individual database, it will provide you the list of web transactions that were performed by this particular operation. So this will allow you to narrow down or help you to isolate the root cause of the performance slowdown. Under the JVM tab, we will be able to monitor the JVM metrics of that particular Java-based application. So like the heap memory, the non-heap memory, and the CPU consumption of this particular JVM, all this can be monitored graphical representation. Moving on to the exception tab. So the exception tab will help you monitor the need for providing a detailed insight into the various exceptions that are occurring within the application. So this tab will help you to identify the different types of exception and also the errors which are causing any issues to the performance of the application. So here, as you can see, some of the error codes that you want to know why this error codes has occurred and the transactions or the exceptions that are involved in this error code. So here we can see that store reports.do has taken some 9 exception count. So by clicking on to it, I would be able to get a detailed analysis of this particular exception. So we will be able to monitor the calls and the method calls involved in it. And as we have already discussed, we will be able to also monitor the stack trees. So this will help the developers or the IT team to understand the line in which the exception has occurred. And this will be a more detailed way of analyzing the overall application performance. Let us move on to generating the reports for this particular application performance monitoring. By clicking on the value, you will be able to get the history report for the desired time period. If it is for the last 30 days or for the last 7 days, how was the minimum and the maximum response time that was consumed for the each and every transaction. So this is an hourly data which is captured, which will help you to understand the responsiveness of the application transaction. Also, you would be able to generate the report for the APDEX code. If you're looking for specifically based on the category like frustration, satisfied, and tolerating, you would be able to generate the report in that way as well. So this will help you to identify the frustrate you time period and try to know all the transaction that has occurred during that particular time and minimize the performance issue. So here in this UI, we have the option to capture this entire data to share it to your IT team. So you have the option of taking a screenshot of it, or in the transaction tab, have table view and the graphical view. So here in the table view, you will be able to export this data in Excel, PDF, or the CSV file format. For configuring the alarms, you would be able to do it by going into the configure alarms page, and you can try to choose the APM Insight monitor. So we know that some of the key performance indicators like the response time, the APDEX code, it is necessary that an alarm should be configured as they will provide us the alerting or the notification when there is a performance degradation in your application. So you can try to get the history data of the response time or the APDEX code. And based on the data that is collected, you can try to configure a threshold based on your requirement and try to associate them with these performance metric over here. So this will help you to receive any alert when the threshold is getting breached during the application transaction. brings us to the end of the training session. So let's have a quick recap of what was discussed. So we have discussed about tracking the application performance using the APDEX code, finding the problems in the application code, tracking the transaction from one application to the another and debugging the issues, identifying the problems in the code stack and how the service map makes it easier for identifying the problems. Thank you for showing your interest in attending the today's webinar.